So good evening. Today we'll do some problem solving related to week number 3 of quantum mechanics and molecular spectroscopy. Am I audible?
Yes, sir, audible.
Okay. Okay, so in last class you might have learned how to calculate the transition probability if you are given a perturbed Hamiltonian which depends on time. So the general formula for this transition probability from one state to another state which depends on time is equal to 1 by h square, then mod of this integral with some limit 0 to t e to the power I omega if t and this perturbed Hamiltonian where this is f is the final state and I is the initial state. Okay, and this is the perturbed Hamiltonian. Perturbation mode. Which depends on time. Okay, so for us the important thing is we have to calculate this parameter, then we have to integrate. Okay, so in this question we are given that psi n are discrete states, means n going from 1 to n, so they are discrete states corresponding to eigenvalues En. So n goes from 1 to n, and the perturbation Hamiltonian is expressed as this, where this part depends on only space and this part depends on time. Then the perturbation is turned on at t equal to minus infinity. Then when the unperturbed system is in ground state psi 0, what is the probability that at time equal to infinity the system suffers a transition to psi of t. Okay, so there are several states n equal to 1, 2, 3 and so on, kth state, something like that. So at time equal to, okay, so it starts from 0 and starts from 0, 0, 1, 2 and so on. Okay, so at time equal to minus infinity the particle was in ground state psi 0. Okay, so and we have to calculate what is the transition probability that this particle can be found at this kth state at time t equal to infinity. Okay, so we have the formula here and we have the this perturbed Hamiltonian. Okay, now first thing we have to do, we have to calculate this parameter. Okay, first thing we have to do, we have to calculate this f h prime of t I. Okay, so our initial state is psi 0, so effectively we can write this as psi f star h prime of t psi of I okay, can be some function of anything, so I am not writing it. integration from minus infinity to infinity. Let's say it depends on x. Okay, so this h prime is given. Actually it depends on r also, so let's write this as r. So this integration, or maybe as the wave function is not given, we won't be able to calculate this. So let's okay, let's not do this. Let's substitute this h prime, which is h prime of r, then e to the power minus t square over tau square by tau root over of pi. Okay, so we are assuming these states are independent of time, so the time dependent part we can take it out. Okay, it will be e to the power minus t square by tau square by tau by root over of pi, and f, only the space dependent part I am writing. So let's rewrite this as h of fi. Okay, then this part will be e to the power minus t square over tau square by tau root over of pi h of fi, which depends on r. Okay, so okay, let me tell you the question again. So we are given a perturbed Hamiltonian, and we have to calculate the transition probability from state psi 0 to psi k, and this is the general formula for transition probability. Okay, so we express this term as this. Now we have to do the integration with respect to time. Okay, now this integration e to the power I omega fi t times this f h prime t I from 0 to t okay, it's not 0 to t, time goes from minus infinity to plus infinity. Okay, so this is minus infinity to plus infinity with t, and this part we just expressed as this term.
Sir, in formula there was some term of omega fi omega and electric field also, no?
That
Those
was,
are not.
yeah, for that our perturbed Hamiltonian was electric field. We were considering, means in that class we were considering that perturbed Hamiltonian that was coming from the Lorentz force, actually QE.
Yes.
For here we are considering different perturbation.
Yes, here discrete. That's a.
No, that example was different. This
Okay,
question
okay,
is,
okay.
yeah, that, this is completely different. For this case, our perturbed Hamiltonian is of this form. Okay, that was a specific case when that molecules are in electromagnetic field. and in this question our system is in this kind of potential which depends on time like this and space
Okay.
like this. Okay, so this term we have expressed like this, so we have to do integration with respect. Hello, any questions?
मोबाइल बंद करो बोल रहा मोबाइल बंद कर
Kavita Sharma, do you have any question? Okay, maybe she's just unmuted. Okay, let's move on. So we have to do integration with respect to time. Okay, so this part is only space dependent, we can take it out. H of fi r, then integration minus infinity to infinity e to the power I omega fi t, and this part is e to the power minus tau square t square over tau square by tau root over of I dt. Okay, these are also constant, we can take these out. Then we have to okay, let's take this out first. This hfi r over tau root over of pi, then this integration e to the power I omega phi t, then is minus t square over tau square this dt. Okay, minus infinity to infinity. So we have two terms, one quadratic, one linear. So we have to convert this as standard term so that we can do integration. Okay, so one thing I can do, I can identify this as a square and this as 2ab. So I have to add some b square term and subtract some b square term. Okay, then this part I can write as a minus b square, then this part I can take it out. Okay, let's assume a is t over tau. Okay, and okay, if a is t over tau, then 2ab is I omega fi t. Okay, so my b will be I omega fi t over a. This is I omega fi t over tau. Okay, so this is 2 times I omega fi tau over 2. My b is this one. Okay, so my a is this, b is this. So what I have to do, I have to add one b square term and subtract one b square term, right? So let me write this again. This is h of fi r tau phi minus infinity to infinity. Actually I can take minus common, so it will be t square over tau square minus I omega fi t, then I have to add b square, so b square will be this sorry for the noise. So I have to add one b square and subtract b square. So b square will be minus omega fi tau over 2. This is the square. 4. Okay, so I have to do minus omega fi square tau square over 4, then plus omega fi square tau square over 4, right? So there was a ith term, okay, so that's why b square is minus. So this term I can write as sorry, are you getting what I am doing?
Yes, sir. Yes, sir. It's integration. Sir.
Okay, so it will be t over tau minus I omega fi tau over 2 whole square. Okay, so my integration will be h of fi r tau root over pi into plus infinity. This part will be minus t over tau minus I omega fi tau over 2 whole square, and this part will be okay. So I am taking common okay, let's put one parenthesis here, then this is minus omega fi square tau square over 4. Okay, this is independent of time, I can take it out. Then this is dt. Actually I have to do integration with respect to t. Then I can do one thing, I can take this tau here, then this integration will be with respect to dt over tau, or you can do simple integration, then this tau will come in the numerator, then tau will cancel, or you can take this tau, this is a constant, so you can take dt over tau. So this is okay, let me take the constant outside first, hfi r tau over root pi, then e to the power minus omega fi square tau square over 4, then this integration minus infinity to infinity e to the power minus, this is like some z square dz. Okay, so this is a standard integration, you can do it, convert it to gamma function, you can try it, then you will get this integration as root over of pi. Just try. Gamma function, you know, I guess this is general form of gamma function. Okay, it's even function, so I can do one thing, 2 times, then limit will be 0 to infinity. Okay, 0 to infinity e to the power minus t square. Okay, no, it's not gamma function, it's some standard integration. Gamma function is just e to the power minus t. Okay, so it's a standard integration, you will find it in Google. You have to do just steps like you have e to the minus x square function, some integration this form, then you have to multiply one more e to the power minus y square function like that dy, then it will be I square, then you have to convert it actually into polar coordinates r theta phi, then it will be easy to do, then finally you will get the integration as root over pi. I am not doing, you can find it easily on Google. So this is root pi. Okay, so we have root pi here, actually I took this tau inside, so okay, this root pi and this root pi will cancel, and our integration is h of fi r, this is prime actually, and this is e to the power minus omega fi square tau square over 4. Okay, so this is the integration, but what we have to do, we have to take its mod square. Okay, so our probability of transition from 0th state to kth state will be h of f is k, our initial state is 0 of r, and e to the power minus omega k 0 square tau square over 4 mod square and divided by h square square. Okay, so it's just 1 over h cross square, h of k is 0, e to the power minus omega k 0 square tau square over 2. So this is the probability of transition from 0th state to kth state. And what is this? This is the energy difference between kth state and 0th state. Right. So our probability of transition depends on this angular frequency, which is the energy difference between the initial and final state, and this is the, actually we don't know the wave function, so we wrote this function as this denotes as k k h of r 0. So we have denoted this as this one. So this is the final answer. So what is the question? So we had discrete energy states psi n goes from 0 to n, and corresponding eigenvalues were 0 en, where n also goes from 0 to n, and we are given a perturbation, perturbed Hamiltonian as this, which has spatial dependency and temporal dependency, and we were asked to calculate the transition probability from psi 0 to psi k, where this time goes from minus infinity to plus infinity. Right. So we applied the general transition probability formula, and we found this answer. Okay, any doubts? No doubts? Actually we did a mistake here. Actually this was a symmetric function, right? That's why I multiplied 2 and took limit 0 to infinity. So there will be a 2 factor here. So I have maybe I have mistakenly, this is minus infinity to plus infinity is root over pi or 0 to infinity. Just check. Okay, this is minus infinity to plus infinity, this is root over of pi or 0 to infinity. Okay, there will be some difference of 2. Okay, so the procedure is this. Any questions? Okay, so I assume no question, so we'll move to the next question. A particle which is initially at t equal to 0 in ground state of an infinite one-dimensional potential box of wall 0 to x equal to 0 to a, okay, is subjected to a perturbation b of t, which is of this form: x square e to the minus t over tau. Then calculate the first order calculate to the first order probability of finding the particle in the final state t for t greater than 0. Okay, so so let me write the energy eigenvalues for this one-dimensional potential well. This is n square pi square h cross square by 2ma square. Okay, and the wave function sin of x is 2 over a sin n pi x over a. Okay, so as in our question it's given one-dimensional potential box, we know the energy eigenvalues and wave functions. Okay, so and the perturbed part is also, this is perturbed Hamiltonian actually, h prime of t, and perturbed Hamiltonian is given. So we were asked to calculate the transition probability. So let's say the ground state is, for ground state n is equal to 1, this is ground state, and we need to calculate the transition probability to first excited state n equal to 2. Okay, so we know the general probability transition probability formula, pf to or pi to pf. This will be 1 over h cross square mod of integration 0 to infinity, or time limit, time goes from 0 to infinity, and e to the power I omega fi t psi of 2. I am writing this final state as psi of 2 for n equal to 2. This is psi of 2 for n equal to 1, psi of 1. So this is h prime. H prime is nothing but b of t in psi of 1 whole mod square. Okay, so we have to evaluate this term. So first we have to evaluate this term actually. So this is psi of 2 b of t psi of 1. This I can write this as 0 to infinity psi of 2 star b of t psi of 1 d of x. Okay, this psi depends on only x. Here you can see. Okay, so what is psi 1 then? Psi 1 of x will be root over of 2 by a sin n is equal to 1, so pi x over a, then psi of 2 is 2 over a sin 2 pi x over a. We know psi of 1, then psi of 2, then we can easily get this integration. Okay, so this is 0 to infinity. Psi of 2 is this. These constants I can take it out as 2 over a, then sine 2 pi x over a. V of x is x square e to the power minus t over tau. Then psi of 1 is e to the power, no sorry, psi of 1 is sine pi x over a. So this integration is time independent, so I can take this out. Okay, then this will be 2 over a e to the minus t over tau integration x square sine 2 pi x over a sine pi x over a dx. Limit goes from 0 to infinity. So you have to do this integration. So it will be easy if you can convert this as two function integration. So here you have three function integration, two sine functions, one x function, quadratic function. So you can further simplify this. You can take this as sine of a and sine of b. Then you can do apply this formula to sine a into sine b as cos of a minus b minus cos of a plus b. So it's pretty standard. You can apply this, and finally you will get the answer as minus 16 a square over 9 pi square e to the minus t over tau. You have to substitute this, and then you apply this integration by parts u v or u dv integration by parts. You will get this. Okay, I am not doing all the steps. So we got this part. Okay, now what we have to do? We have to do the time integration. We got this part. We will substitute this part in here, and then we have to do the time integration. Then our probability I am writing this as 1 over h cross square mod of this integration 0 to infinity e to the power I omega fi t. Then this time dependent part e to the minus t over tau, and time independent part we can take it out. Minus 16 a square over 9 pi square, this it, and mod square we have to do, right? So it's pretty easy now. This is minus 16 a square over 9 pi square h cross square. This is e to the power I omega fi minus 1 over tau into t 0 to infinity, and mod square we have to do, right? So this will be minus 16 a square over 9 pi square h cross square. This will give us e to the power I omega fi 1 over tau t over I omega fi minus 1 over tau, limit from 0 to infinity, mod square, right? Then if you put this limit, you will get minus 16 a square over 9 pi square h cross square. If you put t equal to infinity, it will go to 0, then minus of 1 over this term you will get, then minus I am taking it outside, so I will get this plus. So this is 1 over I omega Fi minus 1 over tau mod square, right? So 1 over A mod square is nothing but 1 over this mod of A square, right? So you might be knowing this mod of Z, where Z is a complex number. I can write this as A plus IB, then mod of this square will be A square plus B square. So in this case we will get 16A square 19 pi square square. This is 1 over tau square plus omega phi square, right? So this is the probability of transition, or let me write from state 1 to state 2, right? So this is the final answer. Any doubt?
No, sir, all right.
Okay, then moving on to the third question. So we are given, consider two level system with zeroth order Hamiltonian is epsilon over 2 sigma z, where this epsilon is a constant and sigma z is polymetrics, z component of this polymetrics. So introducing a time dependent perturbation h prime v cos omega t sigma x, where this v and omega are constants, then calculate the time dependent transition probability for the system to oscillate between two energy eigenstates. Okay, so our h0 is given as epsilon over 2 sigma z. I know the form of sigma z. This is the zth component of polymetrics, so this will be 1 0 0 1, right? So I can write this explicitly, epsilon over 2 1 0 0 1. Sorry, this is minus. Okay, so you see this matrix is already diagonal, so I know its eigenvalues will be plus or minus 1, right, of this matrix. So if I get eigenvalues as plus or minus 1, I know the eigenvectors will be 1 0 0 1. One of the eigenvectors, one representation I can do like this, 1 0 and 0 1, right? Now this perturbation is given as b cos omega t sigma of x, right, where this is constant. So we have h prime and we have states. Let's consider this as 0th state and this one is first state. Okay, so there are two states actually, 0th state and first state, and our perturbation is like this. Let me substitute this sigma x also. This will be 0 1 1 0. So this will be b cos omega t 0 1 1 0. Okay, so let's assume our particle is in 0th state initially, and it will go to final state after some time, right? So my psi 1 is this 0th state, which is 1 0, and my psi 2 is this 1st state, which I can represent as 0 1. Okay, so for transition probability, I know the general form of transition probability. P of t as 1 over h cross square. Limit goes from, say, let's say 0 to t, then e to the power I omega fi t, then this psi 2 h prime psi 1, then for mod square, the integration with respect to time. Right, we have to do this, we have to find this part first, then we have to do the integration. It's pretty simple. The same formula we are applying last two problems. Okay, let's then find out this side 2 h prime t psi 1 first. So I have denoted this side 2 as state 1, then this h prime of t is nothing but v cos omega t sigma of x, and this psi 1 is 0. Okay, so this v cos omega t, this is time dependent, so our state does not depend on time. We can take this out, v cos omega t. So then effectively we have to calculate this. Okay, so sigma x I know, and one state I have written as 0 1. So bra of 1 means this state is, this will be 0 1, then this matrix will be 0 1 1 0, and this state I am writing as 1 0 from here. Okay, now I have to do some simple matrix multiplication. So this is b cos omega t 0 1, first to first column this 0 1, then this multiplication will give me 1. So effectively I have b cos omega t. So this part I am getting as b cos omega t. Right, then I have to do just simple integration, one simple integration, then finally I will get the answer. This will be dt e to the power I omega fi t b cos omega t. Okay, dt I already wrote, 0 to t. So any idea how to solve this? Any suggestion?
So B is constant.
B is constant, I can take it out. Then what I have to do to solve this?
Then e to the power omega fi means omega f, then it has to be broken, and cos omega t e to the power omega t minus e to the power, plus e to the power minus omega t.
Yeah, I can write this cos omega t as
e to the power
I omega t
and plus e to the power minus.
Right, divided by 2. So this part will be 2. Okay, sorry, not 2. B over 2.
Yes, sir. B over
dt e to the power I omega fi t, and this is e to the power I omega t plus e to the power minus I omega t. Limit goes from 0 to t. And do you have any idea what will be this omega fi? Our h naught is given as this epsilon over 2 1 0 0 minus 1. Any idea what will be this omega fi value?
So it is e to the power I omega f minus e to the power minus I omega f.
Yeah, but I want some more information. I have given you this unperturbed Hamiltonian. From this, can you give me this omega fi?
But it is time dependent, no?
No, this I am asking about this omega fi only.
Uh,
This is the only energy difference. I have given you a Hamiltonian. You have to find the energy difference. Actually, in this matrix, you can see two states. Actually, these are two eigenvalues. Let's say this is E2, this is E1, right? Then this omega fi or omega 21 will nothing but E2 minus E1, right? Then E2 is epsilon over 2 minus
minus
epsilon
epsilon.
over.
Uh,
So this is nothing but simply epsilon. Omega fi
epsilon.
is epsilon, right? So we can substitute this omega fi as epsilon. This will be v over 2 0 to t dt for I epsilon t and e to the power I omega t plus e to the power minus I omega t. Now it's pretty simple. V over 2 dt e to the power I omega plus epsilon t e to the power I epsilon minus omega t. This goes from 0 to t, right? This is v over 2. This integration will give me e to the power I omega plus epsilon t over I omega plus epsilon. Limit goes from 0 to t, and the second part will give me e to the power I, sorry,
We can write simple sine I omega plus epsilon t by e. Which actually, if we integrate the cos function, this
yeah,
sine.
you're right. No, we can't do.
Oh, it's a different. Oh, it's a
Yeah, it's
different in.
different. And there is minus here.
Okay. Okay.
This is epsilon minus omega t I epsilon minus omega 0 to t, right? Now this will give me v over 2 e to the power I omega plus epsilon t I omega plus epsilon is minus 1 I think this is the final.
Sir, one doubt. Sir.
Yeah,
When you are putting the at initial value of sigma equal to initially it is 1001 matrix, no? Yeah. It's actually polymatrix 0 minus 1.
yeah, this is
But when H prime you are writing there 0110
this is
minus 1 minus 1.
sigma x, this is sigma z. So h0 was given sigma z, and for our perturbed Hamiltonian is given as in terms of sigma x.
That is, it's perpendicular means that's why minus 1 means both are perpendicular direction sigma x sigma z.
Yeah, if you consider them as vectors maybe,
Vectors. Yes.
but they are not vectors, they are matrices. So previously I have done some problem, like initially the state was in sigma z, then I asked you to calculate what is the expectation value it can be found in sigma x direction, right? So we can project this sigma x to sigma z direction.
Okay. Okay, sir. Okay, sir.
Okay, so if you want you can further simplify this, but this is the okay. Okay, then I have to do mod square also, right? I have done the integration only, then I have to do mod square. This is the probability of transition from 0th state to state 1, right? Any doubts on this?
No, it's
Okay. Maybe if I did some steps on mistakes in step, you can verify, you can do by yourself and you can verify, right? Okay, then moving on to the next question. So next question, we are given a quantum harmonic oscillator with Hamiltonian of this form. Okay, so it's not looking good here. Let me write down. H0 is p square over 2m plus half m omega square x square. So this, from this Hamiltonian you can easily identify this is a harmonic oscillator, simple harmonic oscillator Hamiltonian, right? Because you have x square term here, and our time dependent perturbation h prime is given as this e to the minus t over tau x actually. Then calculate the transition probability from ground state to first excited state. So can you tell me the energy eigenvalue for this harmonic oscillator system? What will be this energy eigenvalue? So this simple harmonic oscillator, this looks like this. Energy labels are labeled like this: n equal to 0, n equal to 1, and it goes like this. So the general form of this energy eigenvalue looks like this: n plus half h cross omega. Might be, you might be remembering now. Okay, so we did one problem in last session related to this harmonic oscillator. So there we wrote this formula En, and corresponding eigenvalue also we can write psi of n of x will be general form will be 1 over root over of 2 to the power n factorial m omega by pi h cross to the power 1 by 4. We did one problem related to simple harmonic oscillator last time, so I'm just repeating the same wave function: m omega x square over h to h cross hn over hn as a function of this root over of m omega h cross x. I guess you have already studied this. Maybe this is known as Hermite polynomial. Okay, so in this problem our n can go from 0 to infinity. So our ground state will be psi of 0 and energy eigenvalue will be E0. E0 will be h cross omega over 2, right? Then our first excited state with energy E1 will be 3h cross omega over 2. Psi 1 is the eigen function corresponding to that excited state. Okay, so we are given this h prime of t as e to the power minus t over tau x cap. Okay, and we know our ground state and first excited state. That means this is my final state, this is my initial state, and I know the general form of wave function. From this I can write my ground state as psi 0 of x. I have to just put n equal to 0, then this part will vanish, then m omega over pi h cross to the power 1 by 4 e to the power minus m omega x square over 2h cross, then h0 function of m omega by h cross x. Actually this Hermite polynomial h of n of any function z, I can there is a table for this, so let me write down h0 and h1 for you. So h0 of z will be just 1 and h1 of z will be 2z. So here z is nothing but root over of m omega by h cross x. Okay, so then this h of 0 is nothing but 1. Then psi of 0
So actually I don't know Hermite polynomial. It's a algebraic part.
yeah, it's algebraic. If you have studied this quantum harmonic oscillator, then you might be familiar with this Hermite polynomial. If, let me write h of 2 for you also. H of 2 will be 4x square minus 2, and you can find this Hermite polynomial. It has a form like h(n) of z. It will be having a form like minus 1 to the power n e to the power z square d to the power n over d z n e to the power minus z square. So by substituting n, that means you have to do that much time of derivatives, then from that you can get h of 0, h of 1, like that. From this is the general form of this Hermite polynomial. Okay, so I have just write down this h of 1 and h of 0, so you don't have to worry. So psi of 0 will be m omega by pi h cross to the power 1 by 4. This part is 1, so we have just e to the power minus m omega x square over 2h cross. So similarly we can write psi of 1 as n equal to 1 we have to put here, so this will be 1 over root over of 2, then m omega by pi h cross to the power 1 by 4 to the power minus m omega x square by 2h cross, then this h of h1 of this function. So this is nothing but 2 of 2z. Z is the corresponding this value, right? So this is 2 of z. Z is nothing but m omega by h cross x, right? So okay, I have psi 1, I have psi 0. So let me write down the general formula for this transition probability. P of Fi, this is nothing but 1 over h cross square mod of this limit for this harmonic oscillator. This function, it has a x square, so it's symmetric, so x can go from minus infinity to plus infinity. So I can take minus infinity to plus infinity, then e to the power I omega phi t, then this psi of 1 of x h prime of t psi of 0 of x, then mod square, okay, of course dt. Right, so now what you have to do, you have to calculate this function. So if you are bored, you can use paper and pen and calculate simultaneously with me. So this will give me psi of 1 h prime of t psi of 0. This I can write in integration form as this. Okay, so okay, sorry, this is the limit for time, not x. So this will go from 0 to t. Okay, so this x will go from minus infinity to plus infinity. So I have psi of 1 and psi of 0, and h of prime I have as this, one space dependency and one time dependency. So what I have to do, I have to take psi 1 of star h prime of t psi of 0 dx. Okay, so I have to take out all the constants out first. So for me these all are constants because these are independent of x, and this as well independent of x. These I can take it out from the integration, and from here this is also constant, I can take it out. So effectively what I will be taking out, I will be taking out 1 over root over of 2 m omega by pi h cross to the power 1 over 2 and 2 m omega over h cross 1 over 2. Then I have this x part and this exponential part, 1 here and 1 here. So this integration will give me minus infinity to plus infinity e to the power minus m omega x square. There are two parts, so it will be only x square, then 2 will cancel, so this will remain, and from here I will have 1x, and from h prime I have 1x, and this time part I can take it out. So what we have, x square dx, and time dependent part I can take it out to here, e to the power minus t over tau. Yeah, now I have to do this integration. So any idea how to proceed?
Consider x square as theta.
Okay, x square is theta. Then let's take this as theta. Okay, it will be easier for us because it's in exponent. So let's take m omega x square by h cross s theta. Then it will give me m omega 2x by h cross dx as d theta. Right. Then I'll have x dx as h cross over 2m omega d theta, right? And from this relation I can get x also. X square will be h cross theta over m omega, so x will be root over of this. Now I can substitute this x square, I can write x into x dx. X dx I'll put this value, and x I can put this value, right? So let's write this integration part, minus infinity plus infinity e to the power minus m omega x by h cross, let's x square, then x dx, right? Okay, let's talk about limit. When x goes to minus infinity, what will be the theta value? Theta will go okay, so it will be complicated. Okay, let's focus here. So you have a x square here and x square here, so it's a even function, right? So I can do one thing. If I have some limit like not minus infinity, let's say minus a to plus a, some function of x dx, and this is a even function, then what I can do, I can write this as 2 0 to a f of x dx, right? So here also same case, I have a even function. If I put minus x instead of x, I will get the same function, so it's an even function. So I can write this integration as 2 times 0 to infinity, and that's down. Okay, so let's change the limit. This is 0 to infinity, 2 will come here. Okay, so when x tends to 0, then theta will also tends to 0, right?
Yes, that tends to 0.
Yeah. When x tends to infinity, theta tends to
Theta also tends to 1.
yeah, then this limit will remain same, 2 times 0 to infinity e to the power minus, we have considered this as theta, minus theta, then x we have substitute like this, h cross theta by m omega 1 over 2, then x dx we have this h cross by 2 m omega d theta. So let's take all the constants out first. So we have h cross by m omega 1 by 2 here and 1 here, so we will have effectively 3 over 2 outside, 0 to infinity e to the power minus theta and theta to the power half d theta. Do you recognize this function? Let me write down like this.
No, sir.
Now this function, have you studied a gamma function in mathematical methods?
No, sir, we have to learn it.
Okay, so okay, maybe I have considered, you already know. Okay, so let's see.
Okay, sir, carry on, we will study it.
Okay, so this is a gamma function. So gamma function, it is related to factorial actually, so you can check it in Google. So okay, so gamma of z is nothing but z minus 1 factorial. I guess I am doing the right. Okay, let's let me check it quickly. Yeah, correct. So gamma of z is z minus 1 factorial. So if you have gamma of 3, then it's nothing but 2 factorial actually, right? Gamma of 5 is 4 factorial. So it's 2 into 1, and this is 4 into 3 into 2 into 1, something like that. Okay, so this integration, this integral is nothing but gamma function, gamma of z. So z I have to calculate from here. So you see there is z minus 1 on this t term. So t is nothing but theta here. So I have z minus 1 as half. So what will be z? Z will be 3 over 2, right? So this function, this integral part I can replace as gamma of 3. Okay, sorry, gamma of 3 over 2. And there is one more property of gamma function, gamma of z plus 1 I can write as z of gamma of z. So maybe it's very unfamiliar to you, but you'll study it in future. So let's move forward. Okay, this is gamma of 3 over 2. So I can write this as gamma of half plus 1, right? Then this will be half of gamma half, and gamma of half is nothing but root over of pi. So in future you will learn. So this integral will give me root over of pi over 2. So effectively what I am getting, 2 I can cancel actually. So it's cross by m omega.
So 2 already previously cancelled. 2
How?
2 m omega here was. No, in integration part.
Okay, there is
No, not there, sir. Sir, little bit later.
okay. Let's
After that.
um, this is theta.
No, next, sir, next. Go to the next. Next line.
Okay, this will give me okay.
No, here
Yeah,
is 2 and yes.
yes, yeah. Thank you. So 2 is cancelled already, so 1 over 2 will remain. So this is 3 over 2 root over of pi over 2. From this I got. So this is only the integration, this part we have evaluated, right? So now we have to do integration with respect to time. So this much we got. So there is no time dependency here. Yeah, there is no time dependency here. So we can take this whole out. So we have to do one more integration with respect to time. Okay, let me confirm. Okay. This is just okay, we have evaluated this part only, right? now we have to multiply all these parts now. So how much I'll get? This will give me 1 by 2 m omega by h cross m omega by h cross half, m omega by h cross half. 1 pi is there, so I can put it here, and 2 is there, 1 2 is there, and from this part I am getting root over of pi by 2 h cross by m omega 3 over 2. Yeah, right. So root over pi cancels, 2 cancels, then we will have only 1 over root 2 h cross by m omega half, right, this part only. So we got this part. I did everything right? Yeah, okay. So you just verify, if you try by yourself, if something is wrong there, then you can tell me.
No, right.
Okay, so we found this value. Now we have to do one integration with respect to time. And this probability is nothing but 1 over h cross square and e to the power I omega fi t, and this part, this is time independent, so I don't bother about it, so I can take it out. Okay, let's 0 to t mod square, and mod square of this will give me 1 over 2 h cross by m omega. Okay, so omega fi, let me just do the integration first. Okay, 1 h cross will cancel, 1 over 2 h cross by m omega. This integration will give me e to the power I omega fi t over I omega fi, 0 to t mod square. So this is over 2m omega h cross, then this is e to the power I omega fi t minus 1 over I omega fi. Okay, so mod of this will give me, like a plus ib mod square, it will give me a square plus b square, right? So if I have ib only, then it will give me b square. So this will give me, this part will give me omega fi square, and from numerator we have to check. You have to this e to the power I omega fi t, I can write it as cos omega fi t plus I sin omega fi t minus 1. Okay, let's take mod square here, omega fi, I already did mod here. Okay, so you see this is a real part, minus 1 is also a real part, this is imaginary part. So mod square of this part will give me 1 over, let me write the constant first, m omega h cross omega fi square, then this will give me cos omega fi t minus 1 whole square plus sine square of omega fi t, right? A square plus b square, mod square means real part square plus imaginary part square. Then if you further simplify this, then you will get 1/2n omega h cross omega fi. Then if you expand this, it will give cos square plus 1 minus 2 cos omega fi t. Okay, then there is a cos square here, sine square here, it will give me 1. Then there is already 1, so it will be giving me 2 minus 2 cos omega fi t, right? Now you can take 2 common, then you can cancel with this 2, then you can simplify. Okay, let me ask you this question here. What will be the value of omega fi in this question?
Yes, sir, omega fi.
So for I we took n equal to 0, for f n equal to 1, so it's e1 minus e0. This for en I already gave, so what will be the omega fi value? Three by 2 h cross omega minus h cross omega over 2. This will give me h cross omega, right? This is e1, this is e0, so h cross omega, my omega fi is h cross omega, right? Understood?
Yes, sir.
Okay, so I can substitute this omega fi, then you can do further simplification. Okay, so h cross yeah, so this will be h cross omega t. So this will be the final answer. You do it yourself once and verify if we did this math correctly or not. Okay, it's just the integration twice. Okay, we did similar problem 4 times, so now let's do some MCQs. Okay, okay, in week 3 this this part is done actually. I hope you can answer this. So your initial Hamiltonian is like this. In presence of electromagnetic field, how this Hamiltonian will change? Your options are A, B, C, D. Take some time and give me the answer. It's already taught in class.
Sir, option D.
Yeah, right. In presence of electromagnetic field, the total momentum actually changes to P plus P prime, where this P prime comes as QA minus QA actually. So this is the right answer, P minus QA, right? Good. Okay, now this one, phase between this vector potential and electric field.
5/2, sir.
Yeah, right, good. Okay, now this one, force on a particle, okay, let's say of charge q plus q in an electromagnetic field.
Sir, option A is
Option
B
A.
plus. No, sir. Q. Option C is
Yeah, maybe
C.
while teaching sir did some printing mistake. It will be V cross B actually. So what is this formula? You do know what is this force called?
Lorentz force.
Yes, right. This is called Lorentz force. See, in presence of electromagnetic field, this electric field directly adds to the force, like depends on the charge of the particle. Right? If there is uniform electric field, and the force will be simply QE. So it will move along the direction of E. But in presence of this magnetic field B, it does not depend on only charge. It depends on the velocity. If the charge is sitting still, then it won't affect its motion if its velocity is zero. It have to move in this magnetic field so that it can feel this magnetic field. So can you tell me, if this charge particle is moving in this direction V and the magnetic field is in this direction, in which direction the resultant uh, movement will be of this charge particle? Forget about this electric field. From this formula,
So in the same direction.
same direction is this direction.
Yes.
No, there is.
No.
You want to write?
B also have horizontal direction.
B have horizontal direction. B has vertical direction. So what will be
Oh,
the resultant force?
then
Resultant
they
motion.
that will be triangular vector multiplication. Means
This is cross product.
45 degree to this direction.
So you are saying if it is B and sorry, if it is B
B.
and this is B, so you are saying the charge particle will move like this.
No, sir. It is actually vector multiplication.
The cross product.
Cross product, yes.
What will be the motion then? Right hand thumb rule.
Point.
It will be
Yes.
outside this paper. It will come out. It will move. If it is B is in let's say y direction and this velocity is in x direction, the resultant motion will be in z direction.
Z direction.
Yeah, because there is a cross product. So let's say there are both electric or okay, let's say okay, this there is a constant magnetic field. So this charge particle Q is moving with velocity v in 90 degrees to this. So this motion, resultant motion will be in out of this paper, right? So then how does this trajectory will look like? Effectively it will come out, but it won't just come straight, it will have some motion.
So it will have some momentum, no?
Yeah,
Yes.
it have
Uh,
okay, yeah, it will have some momentum, but what will be the trajectory look like? So you see, initially it is moving in horizontal direction, then the force is also in horizontal direction, right? And due to this magnetic field, it will feel a Lorentz force in this z direction. It was in already in x direction, now it will feel a force in z direction. So how it will move? Actually it will move in a circular path and it will come out, let's say it's z direction, then this charge particle will move in a helical path and it will move in z direction like this. So it will move in this xy plane, a circle, and it will come out in z direction. So the resultant path will look like this helix, right? You will study this in electromagnetic theory, so it's pretty interesting stuff, that's why I told you. Okay, so the correct answer is C. Okay, so let's move on to this next question. Okay, it has been done in class, can you tell me the answer? There are two functions, one is r and another is f of r. You have to operate this operator del square on this. What will be the answer? Let's
then
take
finally it will come to del FR.
2 del.
FR.
Okay, let me check.
FR. 5 cross 6.
No, not that was, you were saying this commutation relation r h naught acting on this f of r, that will give you that 2 del f of r. This will give you something else. Let's try this. So what you have to do, so del square means del dot del. Okay,
Del del. Yes.
now you have to operate on this r f of r. Okay, so let's do first operator first. So there are two functions and one operator, then del dot this del means del over del r. Okay, so if I apply chain rule, this will give me f of r plus r del f of r, right?
Right.
Now I have to operate this one. So this will give me del f of r in first term. Now second term I have two functions, r and del f of r. This all is a function. Okay, so this will give me, first operating on this, it will give 1, so this will only remain del f of r. Now it will operate on this, then this will give me r del square
Yes.
f of r.
Yes.
So effectively it will give me 2 del f of r plus r del square f of r. So this is the right answer. Okay, so good. Moving on to the next question. Okay, in time dependent perturbation theory, the transition probability between quantum states depends on, you read this and give me the right answer. Okay,
So B correct. Time dependent perturbation.
so it won't
Time
depend.
dependent.
So it won't depend on this H naught. What is H naught? What
No,
is,
no.
it won't depend.
It is not time. It is not time dependent.
No, it's not time dependent, but what you are asking, the transition probability.
Okay.
So what is H naught's eigenvalue? What is the eigenvalue of Hamiltonian energy, right?
Yes.
If you operate Hamiltonian on a state, what it will give? It will give energy. So let's say it's psi n, and this will give En. Okay. So this unperturbed Hamiltonian, it will give you energy. So in this probability formula, you must be remembering this part, integration of E I omega phi t. What is this? This is the energy difference, right? Final
Yes.
energy minus initial energy. So it depends on Hamiltonian, unperturbed Hamiltonian, and it also depends on this perturbed Hamiltonian. So correct answer will be C. So it depends on unperturbed Hamiltonian and this time dependent perturbation X prime. C is the right answer. Okay, so moving on to the next question. Okay, which of the following is not a factor affecting the transition probability in time dependent perturbation theory? Okay, you read and give me an answer. Not a not a factor affecting, not affecting.
Option D.
Duration of perturbation.
No, D.
Okay,
D last steps.
total energy of the system, right? Yeah, you're right. So maybe in next week you might study about this uh, slow perturbation and long duration perturbation. So B is also, on B also this time dependent depends. So the correct answer will be D. It does not depend on the total energy of the system. Okay, right, good. Okay, so moving on to the next question. In a quantum system, if the time dependent perturbation is turned off abruptly at t equal to 0, the transition probability will, okay,
The option C remains constant after
remains constant. So let's say you already give a perturbation h prime of t, some function, okay, which depends on time. Now you turned it off. Now it's t equal to 0. Okay. Remember this probability function formula, p of fi It's e to the power I omega phi t f h prime of t I. Okay, so it's saying t equal to 0 now. Then what will happen? Previously it was a function like exponential function, right? Now suddenly t equal to 0, so probability will decrease, right? Is there a probability of this transition if this perturbation x prime is 0?
If 0 means 1.
Yeah, so because of this function, this was a exponential function because of this term.
Yes.
Now I am putting t equal to 0, so this exponential term will vanish, so it will decrease exponentially with time. This exponential function will vanish, right? So it won't have any transition probability anymore. It will collapse to this ground state instantly. Does it make any sense?
Okay, it will become 0. That's why.
Yeah, the transition probability will be 0 now.
0. Yes. Okay.
Maybe I am framing this question in the wrong way. It's confusing actually. Okay, we'll check it. Okay, let's move on to the. Okay, according to my source, this is the right answer. Okay, let's move on to the next question. Which of the following describes the transition probability in two-level quantum system undergoing Rabi oscillation? Okay, maybe first class, first week you have studied about Rabi oscillation of two states. There you might be remembering how this probability was depending on some function maybe.
It oscillates sinusoidally with time.
Yeah, right. Maybe you might remember in first
Yes.
class, yeah, it was oscillating from two states sinusoidally because this probability was proportional to sine of something, I think.
So,
Okay, good. Right answer is B. Okay, coming to the next question. The transition probability for a quantum system to make a transition from ground state to first excited state is higher than. Okay, get this.
option A.
Because the energy levels are very close. Let's say there are two states, initial state and final state, or just assume a hydrogen atom. there is a nucleus in center and there are orbitals around this. Okay, let's say this is n equal to 1, this is n equal to 2, this is n equal to 3. This third state is very far from 2 and 1. Okay, how I'll make a transition of this electron from one state to another? I'll give some energy, external energy to this electron, right? So let's say I am giving some photon. I have to provide some energy to this electron which is orbiting this nucleus, so that it will gain some energy and make transition to other state. So you might be familiar with this photoelectric effect, right?
Yes.
Yeah. So energy of photon is nothing but h cross nu, where
Yeah.
nu is the frequency of this wave.
Light.
Yeah, frequency of light. Okay. So let's say I am giving some. Okay, let's say this is E1, this is E2. Let's say I am giving some energy E of h cross omega, which is equal to E2 minus E1. Okay, I am giving exactly this much energy, means that I am providing a photon with frequency for which I am matching this energy difference. Then in that case what will happen? This electron will absorb this photon and it will make a transition to the second orbital, right? Now let's say I give, let's say this is let's assume this is visible light. Okay, for this frequency. Now next scenario, I'll give some ultraviolet light. Okay, ultraviolet light means it will have more frequency, higher frequency than this visible light, right? So if I give higher frequency, the more energy will be more than visible light, right? So in that case I can meet this condition like E3.
Yes.
It can meet E3 minus E1. I can provide this much energy to make the electron to transit from first state to third state, right? So it depends on how much energy I am providing, right? So if they are close or far apart, it does not matter. So it does not
Number
matter.
4 is
Yeah.
D is there.
Yeah, you might be remembering from Week 3 there were two delta functions, omega
Yes,
fi,
yes. Omega Fi plus minus omega and
one delta omega fi.
omega Fi plus omega.
Yeah. So that means what? This angular frequency, it have to be equal to this omega fi, means the, what is this? This is the energy difference, final minus the initial state. So this angular frequency will have to match.
Either for absorption or for excitation.
Yes, right. So if it is omega equal to phi, this is absorption, right?
Absorption.
And if it is minus omega phi,
Minus
this is emission.
excitation.
Right. So if it absorbs that energy with this angular frequency, then it will
Come down to the. Oh, sorry.
move up.
Move up.
It is absorbing, right?
Yes.
Then reverse also can happen. If it is emitting the photon, then it is losing energy, then it will come down. So to make the transition, the angular frequency have to be equal to this energy difference. So D is the right answer. Okay, good. Okay. Coming to the next question, which of the following factor does not affect the rate of transition between quantum state in a time dependent partition? Okay.
What is spatial extent of the wave functions? Wave functions. Spatial extent means
Maybe let's assume something. Maybe if you have a potential like this, then maybe if it is spatially extending too much, in that case maybe this wave function go out of this potential. So in that case you can say there is a non-zero probability of finding that particle outside this potential also. So initially there is a particle inside this potential, let's say the particle is inside this potential, but it is described by this wave function. And what is the probability? Probability is nothing but this wave function mod square integration, of course. So if you see, if the function is of this form, there is a non-zero probability of finding this particle outside of this potential. So if it is spread more, then there is a overlap of states. You can visualize like that. If you say this is first state, this is second state, then there is a non-zero probability of finding this particle in the second state also. Actually the answer will be C according to my source. Like in probability there is no mass term is coming, right? But
according to me also in formula there is no mass term.
yeah, but in some cases like we did one problem, right? This harmonic oscillator, in that there was some mass term was coming in probability. So maybe I'm confused now, but according to my source, mass of the particle, it does not depend. So okay, let's assume this is the right answer. Okay, good. Okay, what is the physical significance of omega f? We are using this whole time now. What do you mean by omega f?
B is
D.
second one.
It characterizes the energy difference between initial and final state. Okay. And anything else?
Uh, C also, it quantifies the rate of oscillation.
Yeah, correct. Because this probability will finally come as function of
Yes,
energy difference, right?
energy differences.
So it will come as a function of some cosine. Let's assume this cos of something. Then it comes as a frequency. So it defines the rate of oscillation. So right, B and C. Correct. Good. Okay. When using time-dependent perturbation theory to calculate transition probability, which of the following quantities must be conserved? Okay, it's pretty trivial.
They're all no energy and no energy.
Yeah,
Energy must be gone.
yeah,
Yes.
because we saw this delta function, right? Omega fi minus omega plus omega. So it guarantees that this energy should be conserved. To make the transition, this frequency have to match the energy difference. So A is the right answer. We didn't see any formula for this. So A. Okay, good. Okay, in an electromagnetic wave, the electric and magnetic field are, okay, it's pretty easy.
So option A.
Yeah, right. Thus, if one electromagnetic wave is propagating in z direction, its electric field will be oscillating in this manner, like this, and the magnetic field will be oscillating like this, perpendicular to the electric field. So this oscillation of electric field will induce magnetic field, and oscillation of magnetic field will induce electric field, and it will propagate like this. Okay, good. Okay, this is the last question. What is the relation between frequency and wavelength of an electromagnetic wave? Inversely proportional. Yeah. What is the relation between f and lambda? Can you tell?
2 pi by lambda. 2 pi by lambda.
What is
And
this? This is
frequencies.
yeah, and this is wavelength.
Wavelength.
Then how they are related? Can you tell what is the speed of light in terms of its frequency and wavelength?
H nu.
Its nu is energy, speed of light.
Yes.
This is an f lambda or
F lambda.
nu. So this f is dimension of 1 over time, right? And lambda is dimension of meter. So it will give you meter per second. Okay. So f lambda is the right answer. Okay, so good. This is the right answer. And with this, the questions are over. Okay. Okay, so if you have any doubt, feel free to ask, or if you don't have any doubt now, you can mail me later also. Do you have any doubt?
No, but we have to study a lot more also.
Yeah, okay. Okay, if you have
Okay,
any doubt,
thanks.
you feel free to mail me.
Okay.
Okay, then see you in next class.
Okay.
Bye.
Okay, good night.
Good night.